So starting with the first question, Steve, he's talking about fullerenes. We talked a bit about fullerene. Remember, I told you fullerene is not in your syllabus, but you're going to get questions which would be kind of linked to fullerenes. We did fullerenes in giant covalent structures. We discussed some of it. Okay, we briefly did discuss nanomaterials. So this thing is related to graphite. Okay, when you talk about graphite, carbon is making 3 bonds, and the fourth electron is conducting electricity. So it's a fan-shaped trigonal planar structure, hexagonal structure, and the graphite sheets are arranged one on top of the other, and they are weak van der Waals forces that are between. So they're weak van der Waals forces that are between them, and the sheets can easily slip and slide, which is why they're used as dry lubricants. And they're also very good conductors of electricity because you've got so many electrons that are just moving around. I said, now what were nanomaterials? Nanomaterials were, okay, when we discussed, and remember this was not in your course, but since it's a very popular topic these days, so most of the questions, they have stories about nanomaterials. So just so that you don't get confused, a single sheet of graphite is known as graphene, and when you take that sheet out, you can roll that sheet into a tube-like structure. You can roll it into a ball-like structure, which is known as a fullerene. So this particular question, which we are on, okay, that's the first question. That's about a fullerene. He's talking about. He's saying that they are solid forms of the element carbon. The structure of fullerene is given below. In the C60 fullerene, how many other carbon atoms is each carbon atom bonded to? So if you look carefully, remember fullerenes are kind of made out of graphite. So each carbon atom is bonded to 3 other carbon atoms. Each dot represents a carbon atom. So every carbon atom is bonded to 3 other carbon atoms.
Yes, sir.
Okay, is this clear?
Yes.
Yes, sir.
So it's bonded to 3 other carbon atoms. Next one is that he's saying that fullerene has a relative molecular mass of 840. So this entire thing has an MR, or a molecular mass, of 840. So the next question is, how many carbon atoms are there in one molecule of this fullerene? So how many carbon atoms are there? Now we know that carbon is 12. So how many carbons should join up? Like one carbon is 12. So in 840, how many carbons do you have? You're going to divide 840 by 12. What do you get? Anyone? Any idea?
70.
70, exactly 70, right?
Exactly 70.
Okay, so it's exactly 70 carbon atoms. So that's it. The next question is, I mean, this part B is not really about chemical bonding, but it's about separation techniques. Now, if you read carefully, remember fullerenes are one form of carbon. I mean, you have graphite, you've got diamond, but out of this graphite sheet, you can make lots of other forms of carbon. Carbon can exist in many, many different forms, not just the 2 forms that you're studying. I mean, you just studied graphite, and you studied not SiO2, you studied diamond. These were the 2 forms that you studied, but remember, carbon can have many, many forms. Especially from the sheet of graphene, you can make many things.
Yes.
I said, now, does anyone have a question? I said, now this one. The question is, fullerenes are soluble in liquid hydrocarbon. Now, what's a liquid hydrocarbon? Liquid hydrocarbons are normally your like petrol is your liquid hydrocarbon. The things that you burn, the gases, most of the fuel that you use, those are hydrocarbons. Like the gas that comes in your stove, propane gas or methane gas, the high octane petrol that you fill your tanks with, diesel, etc. These are all hydrocarbons, such as octane. So he's basically talking about petrol. So I'm just giving this information so that you can solve this question. So fullerene is a substance that's very soluble in octane. And he's saying other solid forms of carbon. What are other solid forms of carbon? Like diamond, graphite. These are other solid forms of carbon. And he has stated, etc. He stated that other solid forms of carbon are insoluble. So describe how you could obtain crystals of fullerene from soot, which is a mixture. Soot is the black substance that you have when you burn something. Like if you burn wood, you get this black substance. So that's carbon. So soot. He's saying how could you obtain crystals of fullerene from soot, which is a mixture of fullerenes and other solid forms of carbon. So everything is mixed up. Okay, so you've got diamond, right? You've got graphite. You've got fullerenes, etc. They're all mixed up. So this is your soot, and he wants us to extract specifically crystals of fullerene. Now, the only information that's provided in the question is, now remember the question is using a lot of difficult terms, but the question is very simple. Now, the only information that he has provided is that fullerenes are soluble in liquid hydrocarbons like octane, and other solid forms are not soluble. So there's only one substance that's soluble in octane, which is petrol, and that's this one. So what method would you use? What steps would you use? Can anyone guess? Amna, do you have any idea?
Sir, could we maybe add a liquid hydrocarbon into the mixture and then use filtration, and then afterwards maybe use crystallization?
Okay, so dissolve. The first step would be to dissolve this soot in octane. I mean, they've already told us if you dissolve it in octane, what's going to happen is the fullerene over here, this one would dissolve. Okay, that's going to mix. The other solid forms are not going to mix. So let's think of petrol. There's this beaker that contains petrol, and you put this entire thing in this. Only the fullerene would dissolve, and all the other particles, they would all be like graphite and diamond and all the other stuff, they would all settle at the bottom because they're not soluble. So you can filter them out. So dissolve soot in octane, and you filter out the other solid forms of carbon. Is this
No
clear?
filter पेपर से filter करेंगे.
Hi, exactly.
Okay.
So filter out other solid forms. Achha, is this clear to everyone? Ajita, is this clear?
Yes, sir.
Turhan? Okay.
Yes, sir.
Achha, you filter out the other solid forms of carbon. And once they are gone, so these solid forms are gone, you can simply crystallize it. What's the process of crystallization? That you want crystals of, you evaporate the filtrate, like you can evaporate the petrol to crystallization point. And you cool gradually to obtain. So you've got fullerene dissolved in petrol, and you can evaporate the petrol or octane, which they are stating, and that will leave you with fullerene. So cool gradually and filter out crystals of. So this question was more about separation technique. So that's your answer, the green and the blue one. You dissolve soot in octane. Fullerene would dissolve. The other solid forms of carbon are not going to dissolve. And the other solid forms can simply be filtered out. They can be removed because they are insoluble. And you're left with fullerene in petrol, and you can evaporate the petrol. You can evaporate the filtrate to crystallization point and cool gradually and filter out the crystals of fullerene that are formed in that. Okay, is this clear?
Yes, sir.
Yes, sir.
Okay, next one. You've got a mixture of a fullerene and potassium is an excellent conductor of electricity. Which other form of solid carbon is a good conductor of electricity?
Sir, graphite.
Okay, so we studied that graphite is a very good conductor of electricity. Next one is explain why metals such as potassium are good conductors. Why do metals conduct electricity?
Because they have free electrons.
Okay, so they've got free delocalized electrons. This was what the metallic structure looked like. We did, I mean, this was metals, right? So this was the giant metallic lattice. Where you have metal ions, because all metals like to lose electrons, so they form positive ions, and the electrons are kind of just roaming around doing nothing. So the electrons are negatively charged and they can freely move around, so they can carry charge. So the answer to this question would be it's going to be a one line answer. It's going to be free moving electrons.
सर इसका आंसर ये हो सकता है फ्री मूविंग आयंस
No, the ions are not moving. Okay, remember that. I think, wrote in the notes as well that uh, remember this: the ions are not moving. Okay, I'm just going to write this. Ions don't move. Okay, what
ओके
is
सर
it? What is electricity? Electricity is is a stream of charged particles, right? So electricity is a stream of charged particles. Now the ions are not moving; it's the electrons that are moving around. So remember this: be very careful not to write ions. You're going to get 1 mark for free moving. The other one would be for electrons. Then you've got mixture of fullerene and potassium has to be stored out of contact with air. There, this is a chemical reaction, so we can ignore that. Achha, this one. He's saying write an equation for the reaction between lithium, and over here he's asking you to draw the dot and cross diagram of lithium and nitrogen. The first thing is lithium 3 and 7, it's in group 1, and you've got nitrogen, which is 7 and 14, and that's group 5. Can anyone tell me, is this ionic bonding or covalent bonding between the two?
Ionic bond.
आयोनिक
Okay, so it's a metal versus a non-metal. So metal would lose electrons, non-metal would gain electrons. So we've got lithium. Lithium has 3 protons. So you've got lithium, 3 protons. It has 3 electrons. It's in group 1. So how many electrons would it lose?
1 सर
So it's going to lose 1 electron. Group 1 always loses 1 electron. It's going to get a charge of, what charge would it get?
पॉजिटिव 1
It's going to be positive 1. Nitrogen, on the other hand, has 7 protons, so that means 7 electrons. 7 electrons meaning draw that in cross. As I was actually supposed to do the other way around. As anyways, it's 2 and 5. So how many electrons does nitrogen gain?
सर
3.
3
It needs 3, so it's going to gain 3. And it will get a charge of minus 3.
Negative 3.
So this loses 1. And that gains 3 electrons. So what is the next thing that we should do?
सर multiply with 1
The electrons gain and loss must be equal, right? So lithium is losing just 1, but nitrogen is gaining 3. So the simple way was that if this has a charge of minus 3, multiply this by 3. And multiply this by 3. And if this has a charge of plus 1, multiply this by 1, which you don't really need to do that because it's already 1.
okay
So that automatically means that if you have 3 lithiums, they would lose 1 electron each. So that means total of 3 electrons would be lost. Is this clear?
okay sir
Yes, sir.
And remember to draw all the electrons, because if they had stated in the question draw the outer shell electrons only because a lot of people have this habit of just drawing the outer shell electrons. Make sure that you draw all the electrons. All electrons, they must be drawn, not just unless it's stated in the question. You should draw all electrons. Okay? So now, just hold on 1 second. I said next one is Now he's already stated nitrogen fluoride is a covalent compound. Draw the first thing. Remember to draw. Don't draw the circles first. Nitrogen is in group 5. How many bonds would it make?
3.
3.
And they've already given you the formula. It's NF3, so it forms 3 bonds, right? So nitrogen is going to form 3 bonds with 3 fluorines. Fluorine is in group 7. So how many bonds would it make? It's only going to make
1.
1.
1 bond. Okay, that's it. So that's the dot and cross diagram. It's going to be nitrogen, and there would be 3 fluorines around it, and single bonds, right? So
Yes, sir.
there's going to be 1 electron shared each, 1 electron shared each, 1 electron shared each. The last thing is you're going to make sure that all of the atoms have 8 electrons. So nitrogen needs 2 more. Fluorine's electrons would be in crosses. 1 second. So this should be all crosses. So you need 6 electrons over here. You should draw the remaining electrons. And this one will also have 6 electrons. Okay, is this clear?
Yes, sir.
I said then the next one is lithium nitride has a high melting point, whereas nitrogen fluoride has a low melting point. Explain why the melting points are different. Why does NF3 molecules have low melting points? Like there's an NF3 molecule and there's another NF3 molecule. So what's the reason? What did we study about this? That ionic compounds, specifically covalent compounds. Let's focus on covalent compounds. Why do they have low melting and boiling points? Because they have weak intermolecular forces. Like if you have a covalent molecule, the molecules don't have any charges because no one is losing or gaining electrons, they're sharing electrons. So which is why they have weak intermolecular forces. The bond is very strong. Like in an HCl molecule, the bond is very strong. But the one HCl molecule and the other HCl molecule, they don't have anything in common. They don't attract each other. So which is why they're usually in gases and they have low melting because it's very easy to break these intermolecular forces. In ionic compounds, on the other hand, like lithium nitride, in ionic compounds we studied that they have giant. Where did we study? So in ionic compounds we studied that they had giant lattices. Like every ion had a charge. One was negative, the other was positive. Then you had negative, then positive. So they were all attracted to each other. So it was a giant structure with lots of ionic bonds, a negative charge attracting a positive, positive attracting a negative. So they were all kind of attracted to each other. Is this clear?
Yes, sir.
Yes, sir.
So what you're going to mention over there is for NF3, you're going to write that NF3 has a simple molecular lattice. So they form these simple molecules where one molecule and the other molecules, they don't really attract each other. So it has a simple molecular lattice or structure. I mean, structure would be better. And remember to phrase your answers properly with weak intermolecular forces. So less energy is needed to break those intermolecular forces. Which is why I mean, these molecules can easily sort of turn into gas. They can go their separate ways because the force of attraction is not very strong between them. So less energy is needed to break those intermolecular forces. Or the other way around is you could have explained why lithium nitride has a high melting point because it has a so because you were given only 3 lines, you can either write why this has a low melting point, or why lithium nitride has a high melting point. So the other way to lithium fluoride, sorry. So the other way around that was that lithium fluoride has a high melting point because it has a giant ionic lattice with strong ionic bonds. So large amounts of energy are needed to break those ionic bonds. Is needed to break those bonds. Plus, it's a giant structure, so that means there are lots of ionic bonds. Is this clear? So you're going to write only one of this.
Yes, sir.
All right, sir.
Next is you have why is he's saying you have to be very specific. Why is graphite soft? This is graphite.
Sir, is it because of the weak intermolecular forces?
Okay, again, remember
It has layers.
ex- so you're going to talk about the intermolecular forces. They're very weak. So the layers can easily slip and slide over one another.
Yes, sir.
So uh, sheets of graphite or layers of graphite have weak intermolecular forces. So they have weak intermolecular forces. And the sheets can slip and slide easily. Why do they conduct electricity? Why does graphite conduct electricity? Graphite has what?
It has free electrons because it's not bonded to four other carbon atoms.
Exactly. So it's got free moving electrons. That's why it's capable of conducting electricity. Uh, State to use soft. Where do you use it?
So for lubricant,
Okay, so it's used as a dry lubricant. And the other one is it's a good conductor of electricity. Where do you use graphite for as an electrical conductor?
In batteries,
Okay, so as electrodes in batteries. So the terminals are usually made out of graphite. Describe the macromolecular structure of I mean, this is silicon 4 oxide or SiO2. So they're asking you, it's just 1 mark. So you just have to give 1 mark explanation for this. So where was SiO2? SiO2 was kind of like diamond.
yes, sir.
Okay, it was. Where is SiO2? Okay, it's over here. So you had diamond. It was tetrahedral. Diamond was tetrahedral. Carbon was bonded to four other carbon atoms in a tetrahedral arrangement. SiO2 was kind of similar as well, except for the fact that in that it was tetrahedral, but Si was bonded to four oxygens, and the oxygens were making two bonds. So they were bonded again to silicon. The silicon was again bonded to four oxygens, and the oxygen was again bonded to silicon. So it just kept on repeating. So it was tetrahedral as well. So one way to describe this structure is this is the description that it is tetrahedral. It has an angle of 109.5 degree. Like all the bond angles are 109.5. I mean, look at this pyramid. The angles of the sides of this pyramid would be 109.5. And each silicon atom is bonded to four oxygens, and each oxygen is bonded to two silicon atoms. So we're going to use that one probably. So it's just 1 mark. You can write that each Si is bonded to four oxygen atoms, and each oxygen atom is bonded to two Si atoms. The other thing that you could have written was that it was tetrahedral around the silicon atom. And the bond angles were 109.5 degrees. Next is you've got predict two physical properties which which diamond and silicon 4 oxide have in common. So diamond and silicon 4 oxide were kind of almost the same structure. So what were the two physical properties that are common?
So they both were pyramid shaped.
Physical properties is not about. I mean, remember, differentiate between physical properties and the structure. Okay, structure is different. Pyramid shaped, etc. That's the structure. Okay, we're talking about physical properties. Physical properties, melting points. Do they have SiO2 and diamond? Do they have high melting points or not?
G said they have high
Yes,
melting
sir. They have high
points.
melting
Okay.
points.
And remember, I told you SiO2 is a ceramic material, which means that ceramics, I told you, were substances that can resist very high temperatures. So you make clay ovens, TK, you make clay pots for heating, etc. So it's not as the melting point is not as high as diamond, but it's still pretty high. So it's and it's strong as well. Like if you take SiO2, if you take clay, like you make pots and pans out of clay, different things out of clay, so they're kind of really strong as well. Uh, Most of the rocks that you see around you, they are SiO2. They are a structure that contains SiO2. So those rocks are really really strong as well. I mean that rock is crushed to form sand. That's where you get sand. So predict two physical properties that so they're very strong. Strong, having high melting points. Tell me one other property.
They're bad conductors of electricity.
Okay, they're not because they don't have any free moving electrons. All the electrons are involved in bonding. So they're poor conductors or bad conductors of electricity. I said next is explain the term Ionic lattice. So remember we did explain this. It's a lattice is a regular arrangement of particles. Ionic means it's a regular three-dimensional arrangement of particles. But since he's talking about specifically talking about Ionic lattice, so it's a regular three-dimensional arrangement of uh, positive and negative ions.
Yes, sir.
ठीक है, positive and negative ions. In this lattice, the ratio of positive ions to negative ions is 1:1. In the lattice of a different compound, the ratio of positive ions to negative ions is 1:2. Suggests why this ratio varies in different ionic compounds. So why is the ratio different? I mean, what's the simple answer to this? Like in Mg and Cl, Mg is in group 2, so it loses 2 electrons. Cl is in group 7, it gains just 1 electron. So there would be 2 Cls in the lattice. So why is the ratio different? Because uh, different atoms gain and lose electrons. So they gain and they lose different amounts of electrons. Number of electrons. ठीक है, is this clear?
Yes, sir.
Yes, sir.
So next is just 1 second. As the next one is, you've got give three physical properties of ionic compounds. What are the three physical properties of ionic compounds?
Sir, they are strong conductor of electricity.
They do conduct electricity, but in what state? I mean, they do have charged particles, right?
So, and when they are dissolved in water,
ठीक है, molten or aqueous?
yeah, more than aqueous.
क्योंकि the ionic lattice is given above. The ions cannot move around. They can't. They can't conduct because they can't move around, so they can't carry charge. They can't transfer charge. But when they're molten, the ions can move around, or when they're aqueous, that means the ions are scattered in water, so they can move around in water. So that's the first property. What's the second property? Do they have high melting points or low melting points?
Sir,
Sir,
high
high
melting
melting.
and boiling points.
So they always have high melting and boiling points because it's a giant structure and there are lots of ionic bonds. Every positive ion is attracted to every negative ion and so on. And most of the time they've got pretty high melting and boiling points. What's the third property? Turhan, Minal, any idea? What about solubility? Are they soluble or not? Is NaCl soluble?
Yes, sir, they are.
Sir, it depends on the compound.
No, but they would be soluble to a certain extent. That's a property that they would. I mean, it depends. Like how much they would dissolve. That varies, but they always do dissolve. Like even if it's marble, it's not going to dissolve that much. It's going to dissolve a very small amount would dissolve. But you're going to call that ionic compounds they do mix with water, like even if it's a small quantity. Is that clear?
Yes,
Sir,
sir.
हम बोल सकते हैं कि they are strong.
Hmm?
They are strong.
No, you could have written that they're brittle.
Yeah, yes, sir.
I mean, that's also a property because the arrangement cannot be disturbed. Like if you have positive and negative ions, if you hammer it, like even if it's a very strong structure, if it's very, very strong, like marble, you can't disturb the arrangement because if you apply too much force and you disturb the arrangement, the two negative ions should never be together. Or two positive ions should never be together. It's always a negative ion next to a positive ion next to a negative ion. So if that arrangement gets disturbed, then the force of attraction could easily change into a force of repulsion. That is why ionic lattices they crack. That is why your cement structures they crack. That's why your marble cracks. Okay. So they are brittle because they're very sensitive to the arrangement. The arrangement, if it gets slightly disturbed, then the lattice would get disturbed. I said this one. You're saying strontium oxide is an ionic compound. Strontium is in group 2. I mean, you can just look at the valence electrons. That's in group 2. So you can figure out strontium oxide, draw a diagram which shows its formula, the charges on the ions, and the arrangement of the valence electrons around the negative ion. He's talking about strontium and oxygen, right? And he's only talking about the valence electrons. Now you have to be careful. You don't have to draw all the electrons. How many electrons would strontium lose?
2.
Two.
So if it loses 2 electrons, the valence electrons are now 8. So you're going to write strontium and you're going to draw 8 electrons around it. And what will be the charge on strontium?
Positive 2.
And remember, it's an ionic compound because strontium is group 2 and oxygen is in group 6. So oxygen it's in group 6. So how many valence electrons does it have? It's in group 6. Group 6 have 6 valence electrons. It's going to gain 2 electrons from strontium and it will have a charge of -2.
Negative 2.
Okay, so in this question, they were very specific. You were just supposed to draw the valence electrons. So remember, be careful with the question that don't draw just the outer shell electrons, draw all the electrons unless the question says that you have to draw the valence electrons only. Okay, is this clear?
Yes, sir.
Yes, sir.
So this one, try drawing this one. This one is, try doing this question. ठीक है, send me the answer. They've already said that. I think arsenic. Try and figure out arsenic and fluorine. Arsenic is in group 5. I mean, by looking at the electronic arrangement, it's in group 5. It's got 5 valence electrons, so it's a non-metal, right? So he's asking you to draw the dot and cross diagram. That's just a second. This one. Try sending me the answers on this group. On this group, ठीक है? ताकि they remain visible. Draw the dot and cross. Send a picture over here. So ठीक है, let's continue tomorrow then.
Okay, sir. Allah Hafiz.
Okay, take care. Allah Hafiz.
Allah Hafiz, sir.
Hafiz.